Hey folks, we are going to talk about matrix multiplication in this crash course series. And just a quick reminder and a recap, matrix multiplication means multiplying two or more matrices. We are going to focus on two matrices, but the same rule applies if you add more matrices as well. Okay, so let's do that. And I want you guys to just pay complete attention because it's easy to do in terms of understanding, but it's highly prone to calculation mistake, and it happens 101 times. That's the reason you got to be very careful with the matrix multiplication. And as we get into advanced concepts, you will see that matrices and determinants put together, the whole concept is magical when we can do a lot of things using a computer, like I said, advanced graphics, building computer games, cryptography, and all those things, right? Because multiplication is heavily used, and that's the reason this is the most important fundamental concept. Out of all the matrix algebra, if you take, multiplication stands out because the way it kind of does the magic, and which is what we'll see. Okay, and as a prerequisite to this is, in the previous episode you have already learned to find out whether when we multiply two matrices, definitely the order matters, which is on the left and which is on the right. But we also know these two numbers, the columns on the left should match the rows on the right for the matrix multiplication to be defined or to be possible. And we'll safely assume that particular assumption over here. We'll not go into that because we already covered that. And what we'll borrow is, I've also told you the order of the output matrix is this remaining two numbers which is left off, which is row on the left and column on the right. That's the number of elements. When we say 3 by 3, we are going to get output constant matrix of 3 by 3, which is 9 elements, something of this sort. So keep that in mind, and let's kind of jump straight into matrix multiplication. Okay, let's first take the example of a 2 by 2 matrix or matrix. Okay, so let's say we have this, and like we discussed, we know that, or we are assuming that the multiplication exists. So first and foremost, right, let's kind of write it on the sketch, or we just doodle on the left side. What will be the number of elements or rows or columns on the output matrix when we multiply these two matrices? So let's say this is A, and let's say this is B. Okay, or we'll just keep it X because we are using the same notation, AX is equal to B. Let's keep it X for simplicity and consistency. This is X and this is B. Okay, so when we know that A into X, we need to do it. So what is the first thing we need to do? So A is a square matrix which is two rows and two columns, and X also is a square matrix which is two rows and two columns. Anyway, this match, we're not going to worry about that. But the number of elements or rows or columns in the output matrix, which is B, is going to be determined by these two numbers, this row on the left and this column on the right. So that means I know the output matrix is going to have a 2 by 2 matrix. It's going to have two rows and two columns, which is what we see here. And that means I need to have four elements because I'm going to have two rows. This is row 1, this is row 2, and this is column 1 and this is column 2. That's why it's 2 by 2, two rows and two columns, right? Total four elements. So now we know that. Okay, so we need to find out four elements to find out the output of this AX, which is going to be B. So I know that. So let's create some more room here, and so that we don't appear congested. Okay, so now let's talk about here. Okay, what are we trying to do? So what we do is just follow what I'm doing in terms of algebra. So what I'm going to do is, I'm going to take the left. You always start with the left matrix, which is A, and I'm going to go row by row. I'm going to just write the first row. I'm not going to write anything else. On the right matrix, I'm going to go column wise. So this is the right matrix and this is the B. I'm going to just write the first column. Okay. So what's going to happen is, in your output matrix here, output matrix B, we need to find four elements, correct? So the first element is going to be a combined effect of this two, or this row and this column, meaning that I need to take this row on the left and I need to multiply with the first column on the right in a unique way, which is what we see here. So what we do is we take the first element 1, okay, and we multiply it by 5, which is this element, okay, and then we add the second row element and we take the bottom piece on the column is equal into, we just multiply, and it's a sum of two operations. So the rows and columns of each of the matrix or the elements of each of the matrices get multiplied, and then there is an addition in between. And in case you're interested to know where does this formula come from, check out the other videos. This is just focusing on the exam. And then what we do is, okay, we got the first element, which is what you see here. Okay. And similarly, how do I find we can go row by row. So the next row is 3, 4. So I'm going to write it here. I'm not going to write the first row. I'm going to write the second row, 3 by 4. And I'm just going to again take the first column, which is 5, 0. Okay. So one row at a time on the left and one column at a time on the right. So I'm going to do the same thing. I'm going to multiply the first two elements, which is 3 and 5, which is what you see here. And I'm going to multiply 4 and 0, which is what you see here. And then I'm going to put that puppy here. So it's going to be 3 into 5 plus 4 into 0. So we have found two elements of the 4. Okay, so we need to find the remaining 2. We're going to apply the same logic. This time we're going to take the first row, but instead of taking the first column, we'll take the second column. And this is what I'm not going to write here, but you can see I'm going to take the first row. I'm going to take the second column, and I'm going to multiply the same way. I'm going to write 1 into 6. It's a combination of multiplication and addition. I multiply the elements, I put the addition in between, and then I multiply the remaining 2 elements, which is what it is. And that will give you this puppy. And the last is you take the second row on the left, and then you multiply the same column. The column remains the same, the row varies each time you do that, and then you put it here. So that's how you compute the matrix multiplication of a 2 by 2 or 2 matrices with this given order. So when you feed these numbers to a computer or a calculator, they are just going to get these numbers in a specific order. And based on how you feed it, the computer does the magic behind the scenes, and this is how the computer does. This is what internally goes to give you this output. So nowadays, matrix multiplication is done using systems. No one does that. But for exams, to get an intuition, there are a lot of questions around this one, either directly or some advanced concepts where you need to have the concepts of matrix multiplication in terms of taking one row at a time and one column at a time on the other side. And the order matters. You cannot switch the orders. You cannot say this answer is for AX, but if I do XA, the answer is going to be different. Sometimes it may not be impossible, which is what we saw. So that's how we do kind of matrix multiplication step by step. And I took the example of 2 by 2 because it's very easy. And the same thing I've copied from one of the websites, GI Maths here, because the website had this color coded. So for see here, this is the 2 rows and 3 columns. And if you see here, this is 3 rows and 2 columns. So this inner numbers match. So multiplication is possible. And the output matrix is going to be a 2 by 2, which is going to be 4 elements, which is what we see here. And to find those 4 elements, the same logic applies. We're going to take one row. And if you see the color coding, if you take the first row, which is in red, 4 to 4, and you take the first column, which is in red again, 3 to 7, and you multiply it this way. You multiply the individual numbers and you add the numbers in between and you get the answer. Similarly, if you follow the color code, you take this row, and then in this case, they have taken we went in this case row by row. In this case, they are taking first row and first column, and they're taking again the first row and the second column, this one. They have slightly changed the sequence, which is okay. But this is not going to change. It is exactly going to appear the way it is. And they have put the numbers back here. So that's what multiplication means. In case you understand this color coding, then so be it. Okay. So expanding the same concept to a 3 by 3 matrix, which is where most of the problems come. And there is extreme risk when you copy a wrong number or if you miss an algebraic sign. So you have to be extremely cautious. And I put 2 or 3 examples which kind of mean the same. So I'm taking a 3 by 3 matrix over here. So this is a 3 by 3 matrix, and this is a 3 by 3 matrix. And the output is going to be a combination of this outer 2 numbers. So which is a 3 by 3 over here. That means 9 elements. If you'll see, there are 9 elements over here in terms of 3 rows and 3 columns. If you count, this output matrix or the constant matrix is going to have 9 elements because it's of 3 and 3. And how do you find that? The same logic. On the left matrix, the rule is always the same. Whatever matrix is on the left side, you take that row. Whatever matrix is on the right side, you take the first column and do the multiplication of individual elements and then put a plus sign. Sometimes if the element is negative, then the negative sign will come. But in terms of the rule, it's you start with plus, and then based on the sign with the element, you can change it. So if you see here, this is a kind of algebra on first row on the left and first column on the right. And then again, we need 9 elements, right? Then what you do is you take the first row and then you take the second column, right? In this whole thing, the row is going to be the same, and then you do the same logic. And likewise, you take the first row and the third column here. And then repeat this exercise for the next row. For everything, you will have either the row or column constant, and the rest of the things will change based on what elements you take. In this example, if you're trying to fill it out this way, the way example has shown, it's keeping the row constant and it's changing the column to find it. In the example that we took, we did the other way. We kept the column constant and we kind of went with the row. It doesn't matter, but you should plug back the numbers properly into the final matrix, which is a 3x3 matrix, like here, right? If you see here, I put an example. So 1 into 9. So they have taken the first row and then first column, the whole piece. So multiplication and addition in between. Then they leave a space for the next element. Again, this is the same row in the next column, in this case, this one, and then the third column, and so on and so forth. And whatever is the final addition multiplication number, you get this is the output matrix, which we kind of verified how to fill that. So that's what matrix multiplication is all about: taking the row on the left, slowly taking the column, and being careful and finding the output matrix. In exam, the best thing is you determine what is going to be the output matrix in terms of rows and columns or data elements ahead of time. So if you're not getting those numbers properly, you will know that there is somewhere you are kind of goofed up. That's a good practice. And if you are liking the nomenclature where the elements, instead of saying A, B, C, D or different variables, it's suffixed. All the variables are A, but it's suffixed with the subscript of numbers, where the first number, like we have said in the previous episodes, mean the row. So this is like, for example, if I take this means it's this element that we're circling, it's in row 3 and column 2, which is what it means. It's a row 3, this is a row 3, and this is a column 2. Okay, that's what it means. So if you're used to this, then also it's fine, because it kind of exactly tells you which element and which element to take. For example, if you see, I'm taking the first row and I'm taking the first column. So you'll see this combination of A11, B11 and all those things. So the row remains the same throughout in the first row. And then we move row by row, and that's how it is done. So that's how a matrix multiplication is done. Like I said, the order matters, so you cannot switch the orders. So whatever is in the left and whatever is in the right, that's very important. So you cannot switch this. Don't do this, you'll get a wrong answer. So you'll take the row on the left, multiply it, and adding the column on the right. That's how it is. So quick wrap up on matrix multiplication. Hopefully it was clear and not confusing. And we'll be solving a lot of problems using this concept. So this will come time and again. I will see you in the next episode. Thank you.